Okay, so when I started looking at this, because I couldn't keep the variables, which variable went with which axis straight, and I got tired of looking it up. So I started looking at the word. If you look at the letter I, if you make a capital I, it kind of, and put that with your x-axis, the independent variable kind of holds up the entire graph, right? Then I looked at the letter D. I'm like, well, if I make this a capital D, it kind of takes up the whole graph. So the backbone of the D is like the backbone of the Y on the Y-axis, right? So the dependent variable always goes on the Y-axis. The independent variable always goes on the X-axis. And so if I think about what these variables do, the independent variable is what causes the change that I see here, right? Because this is what I'm changing on purpose, and this is what I'm measuring, right? So what I change goes along here, what I measure goes up here, right? So the capital D make that big backbone, the capital I holds up the entire graph. And so when I did that, I didn't forget anymore. Like it just clicked, it stayed in my head. I had a picture of this capital D and this capital I, and it made it make sense. One year somebody had their head kind of like this, and they're like, oh my gosh, if you turn your head sideways, so turn your head this way. If you turn your head this way, what letter does this look like? A capital what?
H.
Guess what direction the x-axis goes?
Horizontal.
Horizontal. There's another connection, okay? So if you keep those two things, that might help you as you try to, so you don't have to flip to this cheat sheet. But if you forget and you're not sure which variable goes where, you have the cheat sheet in your cheat sheet folder. All right, so I'm gonna have you fill in, there's a few blanks. So the variable you change on the X or that horizontal axis causes the effect you observe on the Y-axis. So we like logic. So if you think about it logically, the dependent variable that's on the Y-axis is always going to depend on the change caused by the independent on the X. And that should be an X. I just didn't finish it very well. Therefore, the X-axis causes the effect that we observe on the Y. And so that just kind of reinforces what our variables do, and it reinforces how it works on our graph. Okay? You guys with me so far? So far so good? Okay. So we have three main types of graphs that we're going to look at. Most of the time in here, we're going to look at bar graphs. If you have data that you're trying to just straight up compare, bar graphs are the way to go. If you have data that you're looking at how something changes over time, then you're going to use a line graph. I will tell you which type of graph to use. Sometimes people don't listen to me and they're trying to make a line graph when they should be making a bar graph, and they're like, I don't understand how to set this up. This isn't making sense. So always be clear and sure that you're listening to my directions and instructions, because I try to help make things a little easier for you. I tell you the type of graph I want you to make. Okay, what's going to match our data the best. Sometimes the way I remember time is what you use a line graph for. You know, like if you think of like a timeline that you might see like in social studies, timeline of American history, or timeline of you know, the pilgrims coming over to colonize the colonies, right? Timeline, it's how things, it's dates over time. Well, you make a line graph to show how things change over time. So that timeline, line graph, I don't know, sometimes that helps people kind of remember. And then sometimes if we have a whole of something, we'll make a pie graph or a circle graph. So if you have 100% and you're breaking that into portions, then, you know, a circle graph is the way to go for that kind of comparison. If there isn't a whole or a total, then it doesn't really make sense to do a circle graph. You probably just do a bar graph. Because circle graphs are also comparisons of data, but it's when you have a whole of something. So all the 8th grade students that I have, or all the 8th grade students at Northmore, right? There'd be 100% of 8th grade students. And so from there, you could have different percentages for, you know, what your favorite subject is, or, you know, grades, or whatever it may be. Okay. All right, let's look at a couple things. I just want to kind of see how you guys are with like looking at data and interpreting it. Okay, so here we have a graph. We have A, B, C's, and D's. And so these are grades with Mr. M's students. So they have made a pie graph because he has a total number of students. So that number is, like, however many that is, it's a whole, it's 100%. So because of that, I know I make a circle graph. So it says Mr. M's class grades were graphed, and what is the most common grade? What's the most common grade? Book?
C book.
Okay, C's. All right. So about what percentage received B's? Sarah, what do you think?
25.
Good, about 25, because it's like a quarter of that circle. So a quarter represents 25%. So let me ask this. Do you think, and before you answer, make sure you have a way to kind of support your answer. Do you think that Mr. M had a difficult class? Do you think it was a hard course that they were taking? Raise your hand if you think yes. Raise your hand if you think no. All right, so somebody who said yes, like defend your response. Jonna?
Because there was more C's than A's and B's.
Okay, so you think if it was easy, there'd be more A's and B's. Okay, good. Who said no, this is not a difficult class? Okay, maybe it wasn't well taught, maybe the students didn't have good effort. Good explanations, Nye?
Maybe their teacher didn't teach well.
Okay, that's kind of along what Macy said, like it wasn't like explained very well. Jackson, what do you think?
I was just gonna say like both of them.
What they said? Okay. How many F's were there? None.
0.
How many D's?
Some.
5.
Just a few?
Us too. But then
No. Don't,
Yes.
don't put yourself in that category.
What is the
So, no F's and just a few D's. Smallest percentage got D's. Could somebody argue that, well, if this was a really hard class, wouldn't there be a bunch of D's and F's? So any of those arguments, as long as you can support your answer, that's what I'm more about than like, oh no, you have to match my answer in here. So if I said, I think this was an easier class because there weren't as many D's and F's, as long as I can defend that, that's correct. If you're saying, no, it's a hard class because there were more C's than anything, if it was easy, there should be A's and B's, right? So defending your answer is what I'm more interested in than whether or not, you know, you can get exactly what I'm thinking you should be answering, right? So a lot of times there's a lot of correct answers, and that's kind of where the analyzing part comes in. You know, if you're looking at that data, what's that data telling you, right? And if somebody else sees it differently, well, then you guys can discuss it and be like, okay, no, I see it this way, no, I see it this way, and you get both points of view that way. Okay, so this is a comparison. So one thing that you want to look at with any type of graph, you're always going to need to identify what the bars represent, right? So you have to identify the bars. The other thing is that you should have an axis label. Sorry, I'm trying to, that should work. So really down here, they should say what these bars are. So type of science classes. You should have some kind of title or what I call the axis label. So this is the x-axis. I need to identify what that x-axis is. And I don't mean put the letter X. We all know that that's an x-axis. That's redundant. What I mean by an axis label is what data is shown here. Well, types of science classes. That should be down here. Now I look at the y-axis. Okay, number of students. Okay, I see it going up by 20s. It has a label. that looks really good. The other thing that I really like on this is that, do you see how the numbers go right at a line? It's not that the 80 is in a space. If the 80 was here, I wouldn't know if this is the 80 or this is the 80. So your number needs to be right at a line. Otherwise, it makes it too hard. It's like, okay, is this the 80? Is this the 80? I don't know. If I'm in like this no man's land in between, that's not helpful. Okay, yes.
What if the bar above is 85 and the bar under 75?
Okay, same thing. Like, you know, you can make these increments whatever you want. It's just make sure that you put the numbers or those increments at the line.
Okay.
Good question, good question. All right, so, looking at this, which class had the most students? This is a pretty basic one, just straight, you know, reading it. Brady, what do you see?
Biology.
Good. Biology has the highest number. I just look for the tallest bar, right? Now, which class do you think was the most popular? What do you think, Zach?
Biology,
Why are you saying that?
because there's more people in biology than any other class there was.
Okay, what if I told you biology and earth science were both required classes that everybody had to take? Would that change your thinking?
Yes.
Yeah, right? So like physical science and biology here, these are the two classes that you have to take in high school for science, right? As you become a freshman and a sophomore. That's, you know, so Mr. Trainer and I have bigger numbers than Ms. Durkee does in physics and chemistry. It's because not everybody has to take physics and chemistry. So if you get new information, you might have to incorporate that into your analysis or your understanding of what this data is showing you, okay? So again, sometimes as you get new information, it's like, oh, maybe not. Maybe they aren't the most popular. Maybe it's just a really bad teacher and nobody likes the physics teacher. And so you're like, ooh, okay, nobody's taking physics, or maybe physics is really hard. Maybe that's why the physics numbers are lower. Or maybe it's offered at a bad time, and so those college students don't want to sign up for it because they don't want to take it at 8 o'clock at night. Something crazy, right? So sometimes there's other factors, but just looking straight at the data, you know, you can't always interpret more into it. If you have more information, you have to consider that. But just straight up, definitely, I mean, you know, you can see which classes have the most attendance and which, or enrollment, and which ones have the least, okay? Okay, so looking at a line graph. The other thing that this graph did not have was a title. It'd be nice to know, like, what were they studying, or why were they looking at enrollment, right? Or it could just say, you know, enrollment in science classes at Ohio State University, right? So at least we'd know a little bit more. So the title for the graph, you should learn a little bit about the data that it's showing you. We have an axis label here. We have good increments here. We have the bars labeled, but we should have had an axis label down here. Again, we're missing a title here. Here, I like it because I have an axis label. Day plant was measured. Okay, the day the plants were measured. And then over here we have height. And then this is also really good. They have millimeter. So obviously number of students doesn't need a type of unit to go with it. But here, being the millimeter, I need to know that. Was it inches? Was it feet? Was it miles? Was it, right? And those are our US customary, so probably we should be using the metric. So is it the millimeter? Is it the centimeter? Is it the meter? What unit did they use as they were measuring these plants? Okay, so they're measuring height and they're measuring, or giving us the unit that is included. All right, so that's really good. A lot of times with a line graph, you'll also get a key, right? And that way you can put multiple types of data on one graph and you can compare them easily, but you can keep the changes separate. So hours of daylight, 1, 3, 6, and 9. And so those various lines, you know, here's the 1, here's the 3, here's the 6, and here's the 9. And I can see that pretty easily. Okay. All right. So as I'm looking at this, I see for sure that something was better for the plants than others. So which environment, is best for those plants, based on this data, Jackson?
9 hours or something.
All right, so these plants definitely are some sun lovers, right? They definitely need that sunshine to grow the best. So all other conditions are kept the same water, same food or fertilizer possibly. All of that has to stay the same except for the amount of sunlight that they are exposed to each day. That has to be controlled. And so as you change the amount of sunlight, as days go by, you see the effect it has on the growth. All right, so as you make a change down here, it causes the effect that we see here. All right, and so same thing up here, right? As you change your independent variable, you change courses, it has an effect on the number of students that are enrolled, right? Whether it's because it was a mandatory class, or whether it's because it was a good professor or a bad professor, or a good time of day that the class was offered, or difficulty, we don't know that, but as the course changed, it had an effect on the students. As days go by, the amount of sunlight had a big effect on the height that these plants would grow. Okay. All right. I think let's go ahead and stop there. Let's take a look at, go to the back of your cheat sheet. Okay, you guys see some data here. Make sure yes, making sure that my data was the same as yours. Okay, so as we look at this, right, there's some things, and I will always have like a little mini rubric off to the side, or maybe even on the instructions of the things that I'm looking for in a graph. Okay, so the things that I'm always going to be looking for are going to be a title. Right, so you're always looking for a title, or I'm looking for a title. You're looking at axis labels. Those are like the little titles for the X and the Y. Not saying X and not putting Y, but actually giving a description there. Appropriate increments. So what I mean by increments is you have to go up by the same amount. All right, so 5, 10, 15, 20, you go up by 5s. 2, 4, 6, 8, you go up by 2s. 1, 2, 3, 4, you go up by 1s. Meaning that each space is always worth an equal amount. All right, that's important with the graph. Sometimes we don't have to start our graph at 0, depending on our data. We might start at 50, or we might start at 100. It just depends. But you definitely always need to make sure that you are keeping those space values or those increments the same. All right, does that sound familiar too? Good. All right, so you always have to have appropriate increments. You want your numbers to be as small as possible. So if you can go by 1s and fit all your data, go by 1s. If it doesn't fit, try going by 2s. If it doesn't fit all your data, then try going by 5s. If it doesn't fit, try going by 10s. If it doesn't fit, try going by 20s. So you kind of always start with the smallest space, and then that way it makes your graph spread out as big as possible. All right, sometimes if, you go by 10s when really you could have made each space worth 2, your graph is gonna be really small. Like your data is gonna be just right here, real small, when really if you made each space worth 1, it would spread it all out. Right, and as we start to get some graphs, I will take some of yours as examples, and you'll see where you guys graphed the same data and how different it ended up looking because of how you set your increments up. Okay, and so there, like I said, there's going to be things that you have to make sure that you're showing me everything you need. So you have to include units if necessary as well. So if you measured in hours or minutes or days, I would need to know that. If you measured in millimeters or centimeters or meters, I would need to know that as well. All right, so having the units over on your your dependent variable are super important too. Okay, so take a look at, here's your first one. Let's go to this one. All right, so first thing I usually do is I like to, this is a data table, and we're almost always going to use a data table. All right, so the data tables just help keep our information organized. Most of the time on your paper that I give you, I will already have a data table, and it will have the heading, so you know, like the size of the ball, which typically this is your independent variable, this is what you're changing, and then the bounce height, this would be my data that I'm measuring or collecting. So this is what you would fill in, right, as you do the experiment. Okay, so since my pen's not working, well, maybe I should try it again, who knows? Nope, still not. I would like you to put right here, IV. What do I mean by IV? Macy's got it, independent variable. So independent variable means this is what's changing. So where is this gonna go? Here or here, Xander?
At the bottom.
At the bottom, very nice. So that can be my label, size of ball, right? We're gonna be making a bar graph because we're comparing data. So I know for my axis label, it is size of ball. All right, I want you to put DV above this one. The bounce height is what you are measuring. It's the data that you are collecting. So put the DV, just so you know, like that's where the dependent variable information is gonna come from. And so which axis goes with the dependent? Let's see, Jonna? Good. So off to the side, we're gonna write bounce height here. Okay, so size of ball was with the X. Bounce height, and then we have to include the centimeter. So in parentheses, put cm. I don't really know this whole experiment, but looking at just this data, what could be a possible or a realistic title that we could make? Any thoughts? And there's no real right answer. There's some wrong ones. Like if you said number of unicorns that live in Iowa, obviously that does not match this data at all. But what could be something reasonable, Claire?
Size of ball that matches the height.
Perfect. Absolutely beautiful. Are there other possibilities? Sure. But it just has to be related. It can't be something totally off the wall or crazy, right? It has to match this information. So write a title. Pick a title that you feel comfortable with based on what you see with just this information. Whatever sounds good to you. Next thing, I look at my data range. What's my smallest number and what's my biggest number? So as I look at this, I see 10 and 35. Right, so I have to fit that data into this table. So I look and I see, okay, I always try to count by ones first. Well, I don't have 35 lines, right? 1, 2, 3, I know I don't have 35, so I'm not gonna be able to go by ones, right? Next thing, always try going by twos. Does twos fit? 2, 4, 6, 8, 10, 12, 14, 16, 8, nope. I don't get from 10 to 35. All right, so now I'm gonna go by fives. 5, 10, 15, 20, 25, 30, 35, 40. Yes, I can go by fives. So you need to put 0 and then 5 coming right off this first line, and then 10, then 15, and so the next thing you have to decide, how many bars are we gonna have? Zach? 3. And so one for each size of ball, right? So I need to decide something. It doesn't matter how many squares wide you make each bar. It could be 1, it could be 2, it could be 3. But whatever you do, you need to make each bar the same width. So you can't have one be 1 square wide, and then the next one be 2 squares wide, and then you have one that's 4 squares wide. That gives a false impression that you're trying to show different information with the width or the thickness of each bar. Really, we're only worried about the height, like how far up did they bounce. But if you change and like don't keep the number of space or the number of squares for each bar the same, it gets confusing. Okay, so pick a width, how many squares you want wide, and go with it. Okay, you can also put your bars right next to each other. You can have a space, but keep things consistent. If you skip a space between one bar, skip a space between the next bar. And then obviously each bar goes up to the certain height. I'm gonna go ahead and stop you. We'll pick up on this. I will get my board fixed tomorrow.